Okay, just here to go over the review for today. First section, when we go from, it's easy to think about going from rotation to angle measurement because we know a full circle is 2 pi. So when we're going to go in this direction, from here to here, we just multiply by 2 pi. But to go from here to here, you divide by 2 pi. And when these are fractions, what you're really doing is multiplying by the reciprocal of this, because that is how you divide with fractions. So divide by 2 pi, or this is what we normally do, multiply by 1 over 2 pi. All right, so that is how you do each of those. So I'm only going to do a couple. So pi over 6 right here, when I multiply it by 1 over 2 pi, the pi's cancel out, and we have 1 over 6 times 2, which is 1/12. Okay, and then I'll just do one more, which is the 1/2. Because again, the answer key is posted, so you can check all of your answers. I'm just showing you the process. So right here, the 1/2, actually let's do the 1/6. The 1/6, so we're going to multiply by 2 pi. And since this is a fraction, I'll just put a 1 under it. I can either cross cancel and reduce the 2 and the 6, or I can multiply through and then reduce the fraction. I'm going to do the 2 and 6. So 2 goes into itself once, and 2 goes into 6 3 times. So I have 1 times 1 pi, which is pi, over 3 times 1, which is 3. So that is how you do each of those in this number 1. Number 2, the wheel has a radius of 1 foot, 2 counterclockwise direction angles so that P returns to its original spot. So it's right here. So P could go all the way around counterclockwise. This is positive 2 pi. It could take another lap. That would be positive 4 pi. So every lap is 2 pi, so multiples of 2 pi. For each of those angles, state the distance in feet the wheel has traveled. Well, since the radius is 1, then it's just going to be 1 times that. So for the first one, it's a distance of 2 pi, and for 4 pi, it would have traveled a distance of 4 pi. Find a clockwise angle that would land at P. So it's clockwise, it's in this direction, which we use negative radians for. So still 1 full lap, so negative 2 pi. You could have negative 4 pi, negative 6 pi. You only need 1. Number 3, a rotation takes P to Q, so from here to here. 2 positive angles. So all the way around the circle is 2 pi. So this is 1/4 of the circle, or 1/2 of pi, since pi is over here. So the easiest one would just be pi over 2. But then you could add a full lap to it. And so pi over 2 plus 4 pi over 2, so that would be equal to 2 pi, is equal to 5 pi over 2. So 5 pi over 2. And then 2 negative angles. So going in the other direction, it's a full pi plus a half. So that's negative 1/2 pi, or negative 3 pi over 2. And again, we could add a negative 2 pi to that. So negative 3 pi over 2. Adding negative 2 pi would be adding negative 4 pi over 2, for a total of negative 7 pi over 2. All right. Number 4, we're using the Pythagorean identity to solve each problem. So that's that cosine squared plus sine squared is equal to 1. So if we know the cosine, negative 0.9 squared, and we're looking for the sine, I'm just going to call it y. it's equal to 1. And so y squared is equal to 1 minus negative 0.9 squared. I put this in the calculator and I got 0.19. So if y squared is 0.19, then I would think, oh, y is the square root of 0.19. However, for this point right here, cosine and sine are both negative. So when I have to find the sine of theta, it is equal to the negative square root of 0.19, because in this quadrant, sine and cosine are negative. Part B, I would do the same way. This time we're looking for the cosine. In that quadrant, that spot, cosine and sine are both positive, and cosine would be the x value. So I know x squared plus 0.8 squared is equal to 1, and that means x squared is equal to 1 minus 0.8 squared, which I put in the calculator and got 0.36. So x is equal to the square root of that, which is 0.6. So the cosine of theta is equal to 0.6. All right, you can use your unit circles to plot these points. Pi over 3, pi over 2, pi, those are all like pi over 3 is about right here, that's A. Pi over 2 is right here, that's B. Pi is right here, that's C. We're at D. 5 pi over 6 is a sixth of pi above C, about here, that's D. And 7 pi over 4, 1, 2, 3, 4, 5, 6, 7 fourths of pi, or 7 pi over 4 right here. This is E. Okay, now part B says to name the negative angle of rotation which takes P to the same location. So if this is 1/3 of pi in the positive direction and 6/3 of pi would be a total circle, right? 2 pi. So for A, to get to here going in the other direction, it's going to be, let's see here, 5, so negative 5 pi over 3, okay? So that it's like, you think about if this part is 1/3 of pi, and the whole circle is 2 pi, that's 6/3. So if this is 1/3, the other part is 5/3, right? Because it's 6/3 total, but it's in the negative direction. So negative 5/3 of pi. Every one of those you can think of in that way. So up here, this is 1/2 of pi, and 4/2 of pi is a full circle. The positive part is 1/2. The negative part is 3/2. So for part B, negative 3 pi over 2. Okay, C, this is pi. The other side in the negative direction is just negative pi. So that it's a total of 2 pi. Part of it's positive, part of it's negative. For D, 5/6 of pi. So in 6 of pi, a full circle is 12. So if we have 5 in the positive direction, we need 7 in the negative direction to have 2 pi altogether. So negative 7 pi over 6. And finally E, 7/4 of pi, or 7 pi over 4, all the way over here. So we're just looking at this piece right here, which is negative 1/4 of pi, or negative pi over 4. Okay, number 6. Point P is at 1, 0. Using sine and cosine, express the exact coordinates for point Q in terms of angle theta. Well, we don't know what this angle is. We can make a guess, but we don't know if we're correct or not. So in terms of theta, or in terms of sine and cosine, the exact coordinates for that point q equal to the cosine of the angle. So cosine of theta, comma, sine of theta. Okay, if we knew what theta was, we could get a more detailed answer, but we don't, and we cannot make assumptions. Number 7 has a tiny little typo. I fixed it on the answer cube. I'd already copied those. So find a negative angle that is equal to the cosine of 7 pi over 4. It should say find a negative angle whose cosine is equal to the cosine of 7 pi over 4. So instead of that is, it's whose cosine is equal to the cosine of 7 pi over 4. So 7 pi over 4 is right here. And it's the same angle or the same spot on the unit circle as negative pi over 4. So the angle is negative pi over 4. And so negative pi over 4 and 7 pi over 4 are at the same point on the unit circle. So they have the same cosine. All right. Number 8, this should be labeled graph A. This should be labeled graph B. You're supposed to determine which of those two graphs is the actual graph for which one is the actual graph for the sine of theta. And so the sine of theta starts at 0, has a period of 2 pi, a maximum of 1, a minimum of -1. So both of these start at 0. Both of them have a maximum of 1, a minimum of -1. But this one has a period of 2 pi. This one only has a period of pi. So A is the correct graph for the sine of theta. For number 9, graph y equals the cosine of theta from -2 pi to 4 pi. So cosine, when theta is 0, the cosine is 1. And it has a period of 2 pi, so it has a maximum of 1 again right there, which means in the middle of those two is the minimum of -1. And at pi over 2, cosine is equal to 0. And at 3 pi over 2, cosine is also equal to 0. So this is one cycle of the cosine function. That's how you map it out. And the other cycles are going to look exactly the same. I'm not going to connect them all, but you should have these 5 points shown for every single cycle. So I'm just going start to finish. This is in the middle, here, and here. Okay? So you should have 3 full cycles shown. Number 10, explain why the tangent is undefined at pi over 2 and 3 pi over 2, but 0 at 0 and 2 pi radians. Okay, so thinking about where those points lie on the unit circle. So this is the point 1, 0, and this is the point -1, 0. This is 0, 1, and 0, -1. Okay, so when we find the tangent of these two, this is pi over 2, and this is 3 pi over 2. So the tangent of pi over 2 and the tangent of 3 pi over 2, both are equal to, well, this one's 1 divided by 0, and then this is -1 divided by 0. But both of these divide by 0, so both of those are undefined because cannot divide by 0. However, in those other two places, the tangent is equal to either 0 divided by 1, this is at 0 and this is at pi, or 0 divided by -1, both of these are equal to 0. So the tangent at 0 radians and 2 pi radians is equal to 0. Okay, finally, almost. The quadrants where the following could be possible. So here we have our 4 quadrants. In this one, cosine and sine are both positive. Cosine's negative, sine's positive. Cosine and sine are both negative. Cosine's positive, sine is negative. So cosine is positive in quadrants 1 and 4. Sine is positive in quadrants 1 and 2. Cosine is negative in 2 and 3. And sine is negative in 3 and 4. So, all the angles for which the cosine of theta is negative, grab my little circle. Cosine of theta, so that's our x value. 11 pi over 6 is right here, cosine's positive. 13 pi over 4, so this would be 4 pi over 4, 8 pi over 4, 12 pi over 4, 13 pi over 4 is going to be in this quadrant here where cosine is negative, so circle B. 3 pi over 4 is right up here, cosine's negative, so circle C. Negative 7 pi over 4. So here is 7 pi over 4 in the positive direction. So in the negative direction, here's negative 7 pi over 4. So cosine's positive there, don't circle D. And then negative 5 pi over 6. Here's 5 pi over 6. Its negative is down here. Cosine is negative. So circle that one. And then negative 25 pi over 6. So in 6 of pi in the negative direction, so this would be negative 6, negative 12, negative 18, negative 24, and so negative 25, 6 of pi would be right here where cosine is positive. So don't circle that. And that is the end of the review.